Good night, everyone. We are Team 21. Today, we're presenting the VITA score, a novel risk prediction model targeting on in-hospital cardiac arrest. As an ultimate complication to critical illness, in-hospital cardiac arrest presented with a fatal mortality rate and a relative low incidence. Current ALS guidelines encourage recognize and treat due to the impact of identifying ICA cause on survival. Moreover, under the influence that clinical management can have an impact, survival in ICA had been rising. However, all of the aforementioned principles in improving ICA outcome concern one thing: time. The earlier we can to identify these high-risk patients, the more hope we have to save them. Thus, we aim to create an early warning score, the VITA, to give doctors an early warning of who might be a ticking bomb during your shift. MIMIC4 was used as our main database. In order to maximize the number of included samples, 24 hours prior to incidence was chosen as our primary target. Therefore, patients with less than 24 hours stay and under or over age was excluded. Cardiac arrest was our primary outcome, while death without cardiac arrest was a secondary outcome. To prevent underestimations, we took out patients encoded with ICD-9 CPR code in death and control group, and also patients without any or insufficient vital signs data prior to event. Finally, we add back patients coded with CPR to our cardiac arrest group and obtained 452 ICA patients. Baseline features are selected in 4 levels. As for patient demographic, age and male gender are listed as 2 high risks of cardiac failure. Simultaneously, these 2 characteristics correspond with our cohort picture. In chronic disease, combined comorbidity score and Ilix-Hauser index are applied. For the accurate diagnosis, since respiratory failure is the second most common cause after cardiac underlying, these 2 classifications make up of this part. Moreover, to make use of the innovation in MIMIC4, check-sex-rate annotations was added as additional information. 6 common use vital signs, including O2 saturation, respiratory rate, heart failure, and blood pressure, was used as our timeline feature. However, by looking at the mean value at every hour, we couldn't clearly predict the patient's deterioration. This encouraged us to further feed the numbers into machine learning to see if artificial intelligence could see more things that human eyes can't. In order to standardize the model development in the longitudinal vital sign data, 1-hour survival analysis framework was used. Multiple measurements in 1 hour were condensed using stated standard. Further on, missing value of time series was filled with last observation carry-on method. Finally, all patients were encoded with 24 sets of vital signs. Both vital signs and baseline feature went through smoke, an oversampling method to increase sampling in our cardiac arrest group. LSTM was applied to our vital sign data, while random forest and XGBoost were both tried on the baseline data. All models went through 5-fold cross-validations. Then we first output a prediction based on baseline features, which remained constant over 24 hours. Another second method was implied to combine both baseline and temporal vital sign data to output our final prediction. Coming to our result part, random forest predicted better than XGBoost in cardiac arrest group with an AUC of 0.79 and diagnosis of respiratory failure as the most important feature. In the mortality prediction, random forest also performed better than XGBoost with an AUC of 0.86 and the same number 1 important feature as cardiac arrest. After adding vital signs to our baseline data, our vital score significantly improved, reaching an AUC of 0.93 1 hour prior to cardiac arrest. As for mortality prediction, our AUC reached 0.94 1 hour prior to death. There are now over 50 existing criteria to predict ICA. NUS-MIT, CART, and E-CART are the most renowned ones using conventional statistical model. Although E-CART presented the highest AUC, it was not convenient to use due to the inclusion of lab data. Moreover, in the machine learning group, our vital score outperformed others such as the vitals-only model published this year. Therefore, we compare our vital score to the second best conventional CART score. Using the percentage of cardiac arrest identified, our vital score defeated CART by identifying 20% more events from the beginning of 12 hours compared to the best CART performance, which was 1 hour prior to event. Moreover, our final detection rate was 97%, which represents we will not miss any cardiac arrest patients. Next time, during your hectic and tiring shift, instead of staring at the untrustable and confusing vital sign monitor, we provide you another option. Our high-performance vital score would give you a real-time picture of who might deteriorate in the near future and are currently missed by the standard safety net. Thank you, everyone.